We're going to do an interesting lab looking at the conservation of energy and trying to discover how much energy is lost as heat energy through friction or as air resistance. But before we do that, we're just going to look at a calculation to remind us what's going on. We've got a block with a velocity, distance it's traveling, and the ramp height distance there, and calculate the energy lost and heat due to friction. And so step number one, write down what you know. I always put the initials down so it sort of makes equations jump out at you. And calculate gravitational potential energy. And so in bottom of red, in red you can see its mass times the gravitational constant times the height. That's the height that it goes through, not the height that it starts at. So that's why we've got 2, because it's 2.5 minus 0.5 of a meter, and gives the answer in joules. And the gravitational potential energy at the bottom of the slope will be 0. And so here, step 4, calculating the energy lost, and which will be the potential energy minus the kinetic energy. So it's mgh minus half mv squared. So working out both of those in joules, you get an answer of 148.6 joules. So that's the amount of energy that is lost. Now, that's 63% of the original gravitational energy, potential energy that a machine or activity could do, but actually 63% of it is lost through friction, and there'll be air resistance too. And so we're going on to a Hot Wheels lab. And so we've got a Hot Wheels ramp, we've got a Hot Wheels car or similar, and you'll need flexible measuring tape, long enough to measure the track, meter stick, photo gate timer, an index card, because the photo gate is taller than the car, and you can put the card there and measure its width pretty accurately, and an electronic balance. And so here's the procedure. Step 1, middle at the bottom, mass your model car with the index card attached, so the card is in line with the car and it's high enough to register through the photo gate, but not too high that it doesn't stop the car. Step 2, measure the width of the card. Step 3, on the right, measure the height of the track at the car's release point. Step 4, measure the length of the track from the release point to the photo gate timer. And number 5, note the photo gate time. And 2 things more here, and you can pause to do this. You've got this in a narrative form written down as a list, and you've got some photographs, so you can pause to look at those for the procedure to the calculations. And so your data, and so these are the initials for the different items that are in your equations, and useful equations, gravitational potential energy, kinetic energy, ohm, which is the work done, and P, which is power here for work done over time. Friction between the car and the ramp slows it down and transfers some of the kinetic energy to heat energy. Doesn't completely stop the car, but you're going to work out how much that is. And as with the calculation in red at the bottom, the energy lost here in joules is going to be the gravitational potential energy minus kinetic energy. And towards the bottom of the right, the friction, FF force, equals work done divided by the distance, because the work done is friction times distance. And D is the distance travelled, the length of the track from its initial release point to the photo gate. Then you can solve for the frictional force and indeed take account of air resistance too. And in your conclusion, state your results clearly, referring to the purpose of the lab. What were we trying to do? And then in your evaluation, what data collection worked well, what didn't, and how would you improve the experiment? And then, with very many thanks to the students in Mr. Jollymore's physics class and Washington International School Team Science.
Today it's just measuring one thing. So you're going to take your car, you're going to put, not this big, you're going to cut a little flag, just like before, put it on top of the Hot Wheels car, and then the flag is going to go through the photo gate, and then you're going to get the distance, and you're going to get the time, and I'll give you the speed. So you're going to get the height at the top, you're going to let it go, you're going to get the speed at the bottom, and then you're going to see how much energy did I start with, how much energy did I end with, and then how much was lost. And you should lose, it's like, it might not be 60%, but you're going to lose some energy. If you didn't lose any energy, then come try it. Okay, so I've got some instructions on a piece of paper. You also need to know the distance from wherever you started to, not to the end of the track, to the photo gate. Okay, but because this isn't a straight line, so we got a measuring tape that you can just like put along the track, and it'll bend with the track. Make sure you're not reading inches. Okay, read the centimeter side. You need to be in meters. Okay, so you're going to share the tape. You're going to need the mass. There's a scale over here. Everyone gets their own car. Everyone makes their own flag. And then when you're ready, come on over, don't trip, and drop it from wherever you want. Get the speed at the bottom, and then do your calculations. You just have to do it once, so you don't have to do it multiple times. But everyone does get their own vehicle, so everyone's going to have like a slightly different mass.
Yep, 7. No. It's like 55. Oh, yeah, that's the Wait, are you measuring how long it is? Yeah. Is it going to be the same for everybody?
I'm starting here. It depends on where you start.
Okay, so I'll start there too.
And what's that?
0.01.
Should that take this?
What?
Stop.
Jordy, you have to press reset. I know, because someone press reset.
You're done. What?
Yo, the distance was 1 meter 70. Oh, 70.
No.
Yeah, that's 1 meter 70. Jordy, did you go? Because it was 1.
No, I didn't go. I didn't count. I don't have to the one with car.
I was. Let me go. Oh, what class?
No, it's in WIS.
I'm gonna have to know. How about the other one?
No,
No, you put it all the way. Put it up. Will's is already up. Will's already made it. Wait, what? Yeah.
It is like 65.
No, is it Gobin?
Oh, yeah, how big is this? How big is the diagram?
Half a page. You don't we'll just lay it out. Just put like, just like this. We'll just put H.
What is 35 grams? Wait, so Saudi Arabia has 3.